All right, hello, my name is Brandon Clayton, the Algebra Guy, and today, as you can see on the screen, we'll be talking about modeling and finding equivalent fractions. So look at this little cool bar that you see in front of you that's going to break down equivalent fractions so wonderfully. Just looking at this piece should tell you how to solve every single problem, but that's no fun. Let's walk through it together so we can see how it's done. All right, so I'm going to start off with my questions as usually. The three questions I want to answer today are: what is meant by equivalent fractions? How can we use fraction tiles to find equivalent fractions, as we saw in that first screen? And given one fraction, how can we create equivalent fractions from that? All right, so let's get into it. Equivalent fractions. Let's think about Andy and Bobby and their favorite food again. So remember we talked about them eating pizza in our previous lesson. But let's think about them again. If Andy eats half a pizza and Bobby eats 2/4 of a pizza, have they eaten the same amount of pizza? He ate a half, Bobby eats 2/4, or is one more than the other? In other words, is one half equal 2/4? So we can use fraction tiles to find out whether Andy and Bobby have eaten equivalent parts of a pizza. And we will use something like this, right? So one half, as you can see, let's just talk about this for a second first. I'm going to use my white color. So this first bar up here, with the big one, this represents a whole entity. Matter of fact, each one of these rows represents a whole entity. The next orange row is broken into halves, and the next row is broken into fourths. But they all represent wholes, because in previous lessons you've learned that half and a half gives me a whole thing. A fourth and the fourth and the fourth and fourth gives me a whole piece, because there's 4 fourths, which makes a whole. So all these are wholes. But these are different ways to looking at the fraction so that we can see what equivalencies look like. So if Andy eats 1/2, this portion right here, and Bobby eats 2/4, now we're going to have to use our fourths row. So 2/4 that's 1/4. Here's 2/4. Are these the same thing? Well, clearly they are, because you can see it's halved up right here. So they're the exact same thing. So using these fraction rectangles helps us to understand that these are both equal. What is meant by an equivalent fraction? So equivalent fractions are fractions that have the same value. As we saw in the question just a second ago, that 1/2 is the same thing as 2/4. Let's answer the questions here. Use fraction tiles to find equivalent fractions. Show your results with a figure. Before I do that, because this is such a wonderful model, I want to make sure I just talk about this for a second. So what are some equivalent fractions that we can see? So anything, let's talk about what else is equivalent to 1/2. What else is equivalent to? So we can't say 2/3, because 2/3, this is 1/3, this is 2/3. It goes way right here. That's more than this line right here, which is my 1/2 line. So, but I can say 2/4, right? And I can say 3/6, because it stops here. Or 4/8 is the same thing as 1/2. Or how many tenths do I have? I got 5 tenths here. Or 6/12. So all these are equal to 1/2. You could have even gone another route and said, how many equal to 2/3? So what fraction is equal to 2/3? And we could look and see that this line ends are 2/3, and this line ends are 4/6, right? So we got 4/1/6. So 4/6 is equal to 2/3. 4/6 is equal to 2/3. What else is equal to 2/3? I don't have anything else. Actually, yes, I do, right here. Bam. So it's hard to see, but this line, and it's just mostly because I know this one. I know it's hard to see if that line is perfectly lined up. And saying that, I want to make the point that this is not a good method to use when you're trying to find something that's really close together. So if the division, like 11 and 12, or 13 and 17, if you have those as denominators, those are really small pieces, and you're going to have to draw that very well to see if they line up. And being off just a little bit will throw you off. So you don't want to use this to get accurate, but it does give us a good visual and idea of how equivalent fractions work. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. So we also can see that 8 12 is equivalent. So all of these are equal to each other. They have the actually same value. 4 out of 6 is the same thing as 2 out of 3 and 8 out of 12. But let's get into that a little bit more with our following problems. Use fraction tiles to find equivalent fractions. Show your result with a figure. So how many 8s equal 1/2? So we just did that. How many 8s equal 1/2? So 1/2, use a different color. How many 8s did it take to equal this 1/2? So if I just took this first bar, it looks like I need 1, 2, 3, 4 to equal that 1/2. So it's not perfect there, but it really should be perfect. And I just know that for the reasons that I'm about to teach you. So that's just me not copying it perfectly. But 4 8s is equal to that 1/2. Next problem is similar to that, but now asking me how many tenths equal 1/2. And we can see that this half ends here, and we have 1, 2, 3, 4, 5, as I just mentioned. 5 tenths, I'm gonna write that out just to make sure you see that. 5 tenths equal 1/2 because we got 1, 2, 3, 4, 5, taking up the same space as this 1/2. That's why they're equivalent. And we can see that through this rectangle model. Now we want to know how many 12ths equal 1/2. So we counted these already. 1, 2, 3. I want to see that. 1, 2, 3, 4, 5, 6. 6 12ths equal 1/2. And again, I want to write that out because it helps to kind of visually see it sometimes. Is equal to 1/2. These two are the same value. You can check it in the calculator if you want to. You can say 6 divided by 12 and get a decimal, and 1 divided by 12. And they're going to give you the same value. They're going to give you 0.5 for both sides. All right, what's an equivalent fraction? An equivalent fraction is as follows. Let me see how much I have here. If A, B, and C are numbers where B is not equal to 0, like I always tell you, you can't divide by 0, and C can be divided by 0, right? So we're going to make sure we get that out the way. Then you have this setup. A over B equals A times C, B times C. So equivalent fraction can be created by simply finding some number, we're calling it C, to multiply the top and bottom by. And it has to be the same number. So I could take a number like 1/4, right? And let that be my A and B. And if I multiply, so that's equal to 1 times, let's say 3. And I leave that 4 here, and I say 4 times 3. Notice that my C value is the same thing. If you do the same thing on the top and bottom, and you're multiplying, not adding, but if you're multiplying by that number, it's going to be 3 over 12. And these are going to be equivalent fractions. And you can keep that going forever. You could take this same one and multiply by 4, and multiply this by 4, and that's going to equal 12 over 48. This is another equivalent fraction. So this 12 over 48, 3 over 12, and 1 over 4 are all equivalent fractions. The only thing we did is multiply the top and bottom to make it into a bigger numbers, but they still have the same ratio or relation to each other, the same value. Like I said, if you divided those and found a decimal, you'll get the same exact answer. Find 3 fractions equivalent to this one. From what I just taught you, you can know that 2/5, an equivalent fraction of 2/5 is going to be equal to you taking 2/5 and multiplying it by any number you want to. Let's come up with 2. Multiply the top by 2, multiply the bottom by 2, and that renders the following equivalent fraction. 2 times 2 is 4. 5 times 2 is 10. So this is an equivalent fraction to 2/5. Let's do it again. So let's take 2/5. And we're going to multiply by a different number this time. Let's use 3. We don't have to make it complicated. 2 times 3 is 6. 5 times 3 is 15. So 6 over 15. There's another equivalent fraction. And let's do it one more time. 2/5 times 5. Oh, let's do another color since I'm using the hot pink. So we're going to say multiply this by 5 and multiply the bottom by 5, and that equals 10 over 25. All 3 of these, 1, 2, 3, are all equivalent fractions to 2/5. How do I know? Because all I did was take a number. In this case, it was 2, 3, and I multiply the top and bottom by them to get equivalent fractions. And that's how I knew that the 1/2 was the same thing as the 4/8 and so on, because I could do that in my head and think, oh, it's being multiplied by the same number. All right, let's do the same thing with 3/5, and you should be able to do that yourself. And I'd like you to try it. How would that work with 3/5? So I could take 3/5, and I'm going to multiply it by the top 2, multiply the bottom with 2, and that equals 6/10. So here's one of them. I could do that again. 3/5, and multiply the top and bottom. Let's do another number, 10. Let's do a bigger number. So it's still going to be an equivalent fraction, 30/50. If I reduce this, which we'll talk about later, it'll give me right back to 3/5. Let's get one more, 3/5, and we're going to multiply any number. Let's do 25, just to be fun. So multiply by 25 is going to equal 3 times 25 is 75, and 5 times 25 is 125. These also are equivalent fractions. All right, we got 4/9, and we're going to do it 4/9, and you probably got it by this time, so I'm going to go a little bit quicker on this one. So I can multiply the top and bottom by, just start out with something basic, 2. Give us 8/18. If we did that again, 3, give us 12/27. And 4/9 times 10. And 10 on the bottom will give us 40/90. So all of these, 1, 2, 3, are equivalent fractions to 4/9. Find a fraction with a denominator of 21 that's an equivalent fraction to 2/7. So they're asking us to do something a little bit different. They're saying, what if you have 2/7 and we want the denominator of an equivalent fraction to be 21? So what's the top number going to be? So if you think about that, and I hope you can see what the answer is going to be before I tell you, you remember that in order to have an equivalent fraction, we need to be able to multiply the top and the bottom by the same number. Well, in order to go from 7 to 21, they would have had to multiply by what? By 3. Well, in order to be an equivalent fraction, we need to multiply the top by 3 as well. So that gives us a 6. So we now know that in order to have a denominator of 21 and start out with 2/7, the fraction will need to be 6/21. All right, did we accomplish our goal? You better believe we did. We always do, don't we? What is meant by equivalent fractions? So that's when we can multiply the top and bottom by the same number and it has the same value. How can we use fraction tiles to find equivalent fractions? So I showed you that with those beautiful tiles. Start out with 1 at the top and it broke it down to half and thirds. So we can use tiles that way. Given one fraction, how can we create other equivalent fractions? Simply by multiplying the top, the numerator, and the denominator by the same factor. By multiplying by the same factor, we are yielded equivalent fraction to what we started. So thank you for tuning in, guys. My name is Clayton, the Algebra Guy, and I will see you next lesson.